53 kilograms of plastic are dumped into the ocean every second. That's 3 tons a minute, 200 tons an hour, 4,600 tons a day, and 1.7 million tons a year. As of right now, there are more than 350 million tons of plastic floating around in the ocean. There are many large environmental challenges facing humankind in the 21st century, and this is definitely one of them. Many other environmental issues present some form of economic incentive for their resolution. Greenhouse gas emissions are tied to more expensive gas and the combustion of expensive oil. Pollution and littering on land lowers the value of nearby real estate. In comparison, dumping plastic into the ocean seems like an economically victimless crime. The marine life we kill in the process wasn't going to pay any taxes or contribute substantially to the economy. For this reason, encouragement is needed to help solve this problem. We need to educate people on the issue, encourage them to help, and discourage them from contributing to the problem, using social pressure. That's where DebrisMine comes in. DebrisMine is a social media platform that lets users show each other when they remove debris from the ocean, share relevant educational news, and find communities dedicated to building a better tomorrow. While DebrisMine has long offered the ability to share debris removed with other users and to make posts and announcements, we've just updated it with article finding and sharing features that identify relevant articles online, show these to users, and allow users to share them with each other.
Hey everyone, today I'll be demoing the front-end part of our application that we're working on with Oceanic Impact, and I'll primarily be showing the search feature and Taha will be showing the group feed feature. So I have the app open on an emulator on my laptop, but the app is available to download via an APK file and test it out. So I have the app, this is the login page, this is what the user is greeted with. Pretty intuitive, not too much going on here, and this was not designed by us. So I have this account and let's log in. So once we log in, we're greeted with the home page. This is the progress overview. Again, this is something that was not worked on by us, so I'm not going to go in much detail. And then we have the saved articles over here, and currently there's no news found, but I'll come back to this later. So if you look at the bottom, we have a couple of tabs. We have post, we have groups, we have search, and profile. So I'll show the search because that was primarily what we worked on, and then Taha will be showing something in the groups. So this is the search page, pretty simple. We kept it clean with the design. There's just a search bar, nothing else going on. We can click on it and search. Let's say we want to search for global warming. Because of the way our scraper is set up, it only filters articles from the web page that are related to environment, and so it doesn't show us like information that's not useful. So we can search, and then you see we have all these articles that have come up. I can search again. So now we have some more articles come up. And then what you can click on all these articles. So let's click on this article. Says banana prices to go up, and it tells you a little bit about the article with an image. Once we click on it, we have this enhanced modal that tells you where the article comes from. So BBC in our case, and a little bit more detail. Along with that, we have 3 buttons at the bottom. So this button, what I'll show, we can click on it and it will take us to the web page that has the article. So we have the banana prices to go up article, and you can read all about it. So let's go back to the application. Next, we have this save button. So let's say you don't want to read it right now, but you found it interesting. So you can obviously save the article. And just like that, article is successfully saved. I want to go back and show you something. So after saving, let's go back to the home page. And now we have a saved article showing up. And again, you can click on it and go to the web page, or you can share it from here. Yeah, so let's go back to the search page. We have this article over here. Now the main feature here is, let's say I'm a teacher and I want to share this article, so I can click on this button and it will show me all the groups I am in. Currently I'm only in one group, which is the testing group. So I will click on this. Once you select at least one group, you're allowed to send, and let's send the article. And yeah, just like that, article shared successfully, so we can close that. Okay, and yeah, that was the search feature. And now Taha will be showing you the rest of the part, which is the group and how the article shows up in the group feed.
The feature that I'm going to demonstrate is the group feed feature that is access to the groups tab. The user will click on the group that they have joined. The leaderboard, announcements, and about page are not worked on by us. We will go to the feed page as desired, and the feed page will have a list of articles and activity posts that have been shared to the group. with the additional functionality of liking and comments, it displays a default image along with the user who created the post, if an activity, the date of creation, the title, and if it's an article, they will have the author of the article along with the publication date and a quick summary. To demonstrate this feature, we can share another article, Olympic athletes. Select the group that we want, share successfully. Then we go back to the group, the feed page, and we have the new post. We'll display the profile image, the thumbnail if it exists. The user can continue to like. This is implemented throughout, and then it will stay with the post. And then there's the additional functionality of commenting on the post. The user can create a post, a comment, and then it will stay on the post as such.
Regarding our pipelines, we decided to use GitHub Actions because it was already integrated into GitHub. We didn't settle on using something else like Travis CI because this means that when we hand it off to Oceanic Impact, that we're gonna have to create a new account and make new credentials, while we have another solution that's basically already built into GitHub. So it would make it a lot more convenient, basically. You can also see here that we have a bunch of workflows, front-end CI, front-end CD, deployment, and back-end CI. I'm going to quickly go over each one of them. So front-end CI is the one that's responsible for linting and formatting, as well as testing the front-end. Similarly, for back-end CI, it also tests, lints, and formats. Regarding the front-end CD, this is the one that is responsible for building the APK, and it builds it into an artifact, which is available here. And you'll also notice that we have, for deployment, we have a production environment and a dev environment, and the same thing goes for our CD. So whenever something gets pushed to either the main branch or the production branch, a new trigger happens, which triggers both the deployment to our cloud provider, which is Amazon, as well as a trigger of building the APK on our front-end CD.
Hey, so I'm Sean, and I'm going to explain to you quickly how the scraper actually works. So there's a sources.config.json file, and this file specifically is going to detail all of the sources that the scraper is pulling from, and we're going to be covering that in a section a little bit later on how to add sources to that. But just for now, kind of assume that they exist and that it works. So what happens is that the scraper takes this input from the sources.config.json file, and this is source information that the scraper needs to scrape some articles. Specifically, it's got something called articles_URL, which is a link to a list of article page. So that could be like the environmental tab for MBC. That could be search results from any sort of source. And what the scraper does is it is able to identify all of the links on that page and then find which ones are articles and then travel to those articles to collect information. Now, here's where it gets a little bit more complicated, is that there's two types of configuration for this scraper. There's a default configuration where if you do sort of the default source.config.json format and you don't specify the specific CSS selectors on the article page, the scraper will run through and it's going to do a couple different things where it will use the readability processing library as well as Selenium to render the page and JavaScript and all, and then sort of abstract away the layout of the page. So the issue with sort of creating a default configuration with a scraper is that there are tons of websites out there. I'm not too sure exactly what kind of sources are going to be in sources.config file. And so this configuration works mostly for any web page. And it does this by using the readability library to abstract away a lot of the individuality these websites have. So for example, the HTML structure for these websites could be totally different. You could have an author, for example, being listed as author, as byline, as creator, as a lot of different names. And so the readability library uses heuristics to try to guess what the correct position of that information is, to varying levels of success. But the default configuration does have the drawback that, one, it takes a while to load. Selenium needs to process the page, so it needs to wait, I think, 5 seconds per article, which can take a lot of time depending on what you set the duration of the scraper. Right now it's 12 hours, but perhaps you want something that runs a little bit more. Also, the drawback is that it can have garbage or misinformation sometimes because the readability library is guessing as to what the correct responses and sort of data is. Now, it is pretty accurate, but there are cases in which it will not get the right information or it might not be able to find a certain image. And in those situations, it's nice to use the other configuration called the CSS selector override. Now, this one, highly accurate, very fast, but comes with a drawback, that of which being it requires technical knowledge. You need to be able to go onto a page and manually identify the CSS selectors. If you're able to do that, it runs through Beautiful Soup. It doesn't need to go through Selenium or readability and just instantly grabs those CSS selectors or the CSS tags and is able to transform that into the article data to then later inject that into the database. So you'll see that the CSS selector only uses Beautiful Soup. That's why it's faster. Whereas the default configuration uses readability and Selenium, making use of all of these libraries for sort of different and varying results.
When we took over the project from the previous development team, the application consisted of a monolithic backend built with Django, an Android app created with React Native and Expo, and a Postgres database. The majority of the existing infrastructure was hosted on Heroku. Throughout the course of our work on the application, various elements have changed. We've added a Python microservice that uses Selenium to scrape news sites for environmentally themed articles. Additionally, we've increased the coupling between the database and the monolithic Django backend. This was necessary to make use of Postgres-specific functionalities, such as full-text indexing, which allowed us to quickly vectorize and index news articles so they could be efficiently searched through later. While the previous backend could function on top of any database owing to Django's abstraction, this is no longer the case. While not reflected in the architecture diagram, we've also invested a lot of time into expanding the monolithic backend to support the new features and functions that we've added. In particular, we added a lot of new endpoints for articles, article sharing, and groups of users. Additionally, we chose to migrate from Heroku to AWS as it's a cheaper and more robust cloud platform that allowed us to centralize our hosting for all resources, including the database, on a single platform.
Hello, I'm going to talk to you a little bit about the deployment and how to access the application outside of the scraper. So both the backend and the scraper are hosted on AWS, with an APK file being built on push to both main and production, with our developer deployment and production deployment being created on push to both main and production branches, respectively. Please don't use the production version of the application, as like Oceanic intends to do user testing with this version. We've provided a development version, and the most recent development version of the application is actually accessible via this QR code. So you get the APK link here. As for handoff, there's a few things that we have to do. We'll first add Oceanic as contributors to the GitHub repo that we've been developing on, so they can continue development there if they please. But if they wish to switch onto a different repository, that's all fine. We'll give them the GitHub secrets so that they can have CD work the exact same way. And finally, we'll be moving deployments onto Oceanic Impact's AWS account, which we're waiting on to receive credentials from their technical lead. Thanks.
Here's how you can add a source. So what I have on screen right now is an example of how you would log a default configuration source. So you'll see here that you would need to specify the name of the source as well as an ID, base URL, and article URL. The article's URL, you're going to also have to make sure that actually it has articles. If you put something that's not correct or an article URL that doesn't actually have any articles, the scraper is not going to be able to get you anything. And then here there are some selectors for the source. These are abstracted selectors, so they don't need to be specific. As you can see with the example here is very general article. Link is A, that's pretty common among the majority of web development. And then the thumbnail is .logo. For the most part, these don't need to be there. They're supposed to be abstracted. They still run through readability. And so they don't need to be as detailed as the CSS selector override configuration. So for the most part, if you want to run the default configuration, this is what the JSON edition should look like. If you wanted to run the CSS selector override configuration, as you can see, it gets a little bit more complicated. The CSS selectors get a lot more involved. The way that the scraper is able to identify between the two configurations is whether or not you include this articles_selector field here. If you do, then it's going to go into the CSS selector override configuration, where it's going to take these specific fields: title, content, thumbnail, author, date published, and date edited. And you're going to need to specify exactly what the CSS selector is for the scraper to be able to pick up the article data. You can see so much more or read how to like set up this installation as well from the README in the scraper backend. As well as there's a lot of sort of interesting the way you would get CSS selectors. You can find documentation about this online, but it's through inspect elements and sort of just reading the HTML structure. And so if you wanted to go this route, you're going to need that sort of knowledge. Otherwise, I would default to the default configuration, although it is a bit less accurate. Although we do have checks to like make sure like garbage isn't showing up. You know, it's not just like random ones and zeros on the search page, but it is not as accurate as the CSS selector override would be.
So in this section, we'll be discussing the key learnings that we as a team gathered throughout these 4 phases of the project. Starting off with the back end, I think we as a team should have spent more time, especially between the back end and the front end features, discussing what features were required for each user story and implementation on the front end. So the endpoints could have been more effectively implemented from the start instead of having to go back, add things to the back end so that new front end features could be supported. That happened a lot throughout the project, having to implement new features. As for the scraper, communicating more with Oceanic Impact would have been nice about what exactly they wanted. We implemented a bespoke scraper, but that's hard to update, and after the handoff, we could see it being a problem for them to keep it up to date if they don't necessarily understand how to work with the technologies. So maybe discussing about paying for an API with Genius would have been a good discussion to have from the start. As for the front end, spending more time planning and making it clear with the partners what exactly they wanted, because there was a lot of back and forth feedback of, oh, this isn't exactly what we wanted, and rehashing things. Also, looking into the old team's code from the start would have saved a lot of time. Our D2 was in JavaScript, which we had to change into TypeScript later to allow it to really merge well and work streamlined with the previous team's code. And using component libraries as well and stuff like that would have saved us a lot of time of making everything by hand. On the DevOps side, integrating all of our DevOps onto one account instead of starting with separate accounts would have been much better. Speaking with Oceanic Impact, they had their own account, but because we didn't start off at the beginning, one of their employees who was responsible for that DevOps side was away, so we couldn't merge everything right away. So maybe more communication from the beginning about the handoff process in advance instead of leaving it to the end, and discussing more about deployment and how they want things to be set up in the beginning would have been a lot better and more streamlined. And yeah, one of the reasons we moved to AWS was to satisfy the stakeholder requirements of having deployment being in one centralized place. The previous team before us was using many different services like Elephant SQL and Heroku, which they didn't like, and they wanted to switch away from that. So getting that clear from the beginning and starting from the beginning to plan the handoff process would have been a lot better.